Hello, this is Christian here. In this video, I'm going to complete version B of your first quiz, and I'm going to try to be as comprehensive as possible. Now, in your actual quiz, you don't have to be as comprehensive as me in this video, but for illustration purposes, I'm just going to do all the steps that you might take to get to the solution. And as we move through the problems, I'm going to review some of the laws that we're going to be using in all of these problems as part of your review. So in the first problem, we have to simplify all the following expressions if possible. So for this problem, we have to remember one specific rule of exponents, which is that if you have a to the power of m times a to the power of n, we can simply simplify this as a to the power of m plus n. Okay, so that is the rule that we're going to use. So in the first step, I'm just going to group a similar term. So in this case, I'm just going to put the numbers with the numbers. So 5 divided by 10. A squared times a to the power of 6. And then our b, which we cannot do anything with that. So we're going to have to carry that until the end. Now 5 divided by 10 simplifies as 1/2. And then a squared times a to the power of 6. We use the rule below to get a to the power of 2 plus 6 times b, and that simplifies as 1/2 a to the power of 8 times b. And that is our solution. Okay. Now for part B, we are working with exponents again, but this time they are in a fraction, and we are raising some terms to some outside exponents as well. So we have to remember a few laws of exponents here. So the first law that we have to remember is the following. So if we have a product like this, a times b, raised to some power n, we can simply distribute the n to both factors like this. So this is going to be equal to a to the power of n times b to the power of n. And we also have to remember that if we have a term, let's call it a again, to the power of n, and we raise all of that to the power of m, then we can simply multiply the exponents together. So that is what we're going to do in this problem. So this is going to be the first step. I'm going to use the first rule over here. So the first step is to simplify or expand or massage the numerator in this case. So this is going to be 3 squared times x squared squared. So we're using this law over here. All of that divided by 4x cubed. Okay? We're not going to do anything with the denominator yet. We're just going to work with the numerator a little bit more. So the next step is to apply the exponents to each factor. So 3 squared is 9. X squared to the power of 2, we're going to use this rule here. And this is going to be the same as x to the power of 2 times 2 divided by 4x cubed. And then this simplifies as 9x to the 4th power divided by 4x cubed. Now at this step, notice that we have some power of x in the numerator, another power of x in the denominator. So we have to remember the following law of exponents, which says that if you have some a to the power of m divided by a to some power, let's say n, we can simplify that as a to the power of m minus n. Okay, so that's what we're going to do in this step. So this becomes 9 divided by 4 times x to the power of 4 minus 3. That is following this law. And lastly, this becomes 9 over 4 times x. And that is our solution. Okay. All right, so part C. So remember that radicals are essentially fractional exponents, okay? So when you see something like the square root of something, all we mean is that we can write this as whatever we have inside, which is 25x to the power of 8 to the power of 1/2. Okay, so radicals, all we mean by radicals is fractional exponents. And then the same laws apply. Okay, so that means, again, we're going to use the rule that says that if you have a times b to some power, we're going to apply the power to each factor. So we're going to do the same over here. So this is going to be 25 times 1/2, which means that we're taking the square root of 25 times x to the power of 8 to the power of 1/2. All right. Now the square root of 25 is simply 5. And then over here, we can apply the law that says that a to some power n raised to the power of m is the same as multiplying the exponents like this. So here we're going to have x to the power of 8 times 1/2. And that is the same as 5 times x to the power of 4. And that is our solution. So basically, the laws of exponents apply here as well, regardless of whether we have an integer exponent or a fractional exponent, like in this case. Okay. All right, so let's move on to the next one. So here, we're not dividing or multiplying letters with exponents necessarily, but we are distributing terms. So we have to use the distributive law to distribute this 4 here and here and over here. Over here. Okay. So let's do that. So the first step, I'm just gonna leave this part untouched for the moment. So this is gonna be 2t squared minus 5t. All right. And now I'm going to distribute the negative 4 in all the terms inside the parentheses. Okay. So this is going to be minus 4 times 3t squared minus 4 times negative t, that is this negative over here, negative t, minus 4 times positive 2. Okay. And now we're going to simplify that a little bit more. So this is going to be 2t squared minus 5t minus 12. So we're multiplying 4 times 3, that is 12t squared. Plus, because we have a negative here and a negative here. Okay, so negative times negative becomes plus 4t minus 8. Okay, so now this simplifies even more, because if you notice, we have terms that have similar factors. So here we have some t squared. We have t squared over here. Here we have some t's as well. So we have 5t and we have 4t. And then we have this number that is kind of by itself. So we're going to add or subtract the terms that have the same power of t. So if we do the blue ones first, 2 minus 12t squared, that is the same as negative 10t squared. This corresponds to the blue ones. Minus 5t plus 4t is the same as negative t. And this corresponds to the yellow one. And then the minus 8, that is kind of by itself. So we don't do anything with it. Okay. So this is the solution. Negative t squared minus t minus 8. Okay. All right, so in this problem, we have a fraction that has some other fractions as numerators and denominators. So the first step that I'm going to take is to rewrite this as a product of two fractions. So remember that expressions like this can be rewritten as 3x divided by 2 times the reciprocal of the denominator. And the reciprocal of negative 6 divided by x is x divided by negative 6. Okay. And now if you notice, 3 and 6 have a common factor of 3. Okay, so this becomes negative 2. This becomes 1. And this is actually x divided by 2 times x divided by negative 2. All right, and we can simplify this as x squared divided by negative 4. And that is our solution. Okay. Now, problem B looks kind of ugly, right? So we have a difference of two different fractions, and that as a numerator, and the denominator is h. So you have a really big fraction. So the first step that I'm going to take is follow the same logic I did for part A, which is rewrite the denominator as using the reciprocal. Okay, so this is what I'm going to do. I'm going to take the numerator and leave it untouched for the moment, 5h minus 2 divided by 5. And I'm going to multiply that by the reciprocal of the denominator, which is 1 divided by h. Okay? And now the expression, it's identical, but it looks a little bit better to work with. Okay? So now I'm going to simplify the parentheses because we have to put everything into one fraction. So at this step, I'm going to use the rule of adding and subtracting fractions. So remember that rule says that if you have a divided by b, plus or minus, it applies to both, c divided by d, all I have to do is multiply a times d, plus or minus, depending on the sign that you have. It's just, if it's plus, you write plus. If it's minus, you write minus. B times c, which is multiplying diagonally this way. All of that divided by b times d. So I'm just going to use the same rule in the parentheses over here. Okay. So if we use that rule, this becomes 2 times 5 minus 2 times 5 plus h, all of that divided by 5 times 5 plus h. And remember that all of that is multiplied by 1 divided by h. And now I'm going to get rid of all this stuff because I'm going to need a little bit more space. Okay, so this simplifies a little bit more. So 2 times 5 is 10. Minus, we're going to do this thing, distribute the 2 over here and over here. So this is going to be 10 minus 2h. All of that divided by 5 times 5 plus h. And remember that all of that has to be times 1 over h. And now notice that we have 10 over here and 10 over here. We're subtracting it from each other. So this simplifies as negative 2h divided by 5 times 5 plus h times 1 over h. And now we have an h over here, an h over here, so we can cancel those. And all we end up with is negative 2 divided by 5 times 5 plus h. Okay, and that is our solution. All right. Now let's do the other one, problem C. So in problem C, we now have a negative exponent, okay? So negative exponents in a fraction tell you that the whole term should not be where it is right now, okay? So if you have a negative sign on the exponent, all that is saying to us is that our x cubed should not be on the denominator and it should be on the numerator. Okay, so that is one practical way of thinking about this problem. So this is going to become 2 divided by 5, and our x has a negative exponent, so that means that it should not go on the denominator, and it should go on the numerator. So this is going to be x cubed. Okay, and that is our solution. All right, so for problem 3, we have to multiply to obtain an equivalent expression and then simplify as much as possible. So in this case, we're going to use the distributive law to distribute this term over here, and over here, okay? And then we're going to simplify. It seems like we will have to use laws of exponents at some point, so let's see. So the first term is going to be 5 divided by 3x times this first term in the parentheses. So this is going to be 1/2 x squared minus, because we have a minus sign over here, minus 5 divided by 3x times 9 divided by 5 times x, which is this term over here, okay? Then plus, because we have a plus sign over here, plus 5 divided by 3x times 4 divided by 10, okay? Now this simplifies a little bit more because, for example, we have an x squared here and an x here that can cancel each other, okay? So this is going to become, so remember that when we have, we are essentially using the following laws of exponents. So let me write it over here. So x to the power of n divided by x to the power of m, that is simply x to the power of n minus m. Okay, so we're subtracting the exponents. So this is the same as 5x divided by 6. Okay, so we multiply 3 times 2, we got 6. And then we are writing the x to the power of 2 minus 1, which is going to be just x. Minus, so notice that here we have a 5 that we can cancel with this one. And then 9 and 3 both have factors, a factor of 3 on it. So this becomes 1 and this becomes a 3. And then we have this x over here kind of by itself. So this becomes 3 times x. Oh, I'm sorry, but this x is canceled with this one. Okay, so this and this cancel as well. So all we end up with is just 3. Okay, just 3. And now for the last term, so let's see what we can do here. So this x does not cancel with anything else. There are no other x's around. But this 5 cancels with this 10. So this becomes a 1 and this becomes a 2. So this is actually 4 divided by 6x. All right. But then notice that 4 and 6 has a factor of 2. Okay, so we can simplify even further by writing the following. So this is 6x divided by 6, 5x divided by 6 minus 3 plus 2 divided by 3x. Okay, and this is our solution. All right. Okay, so here we use the distributive property and also some laws of exponents here. All right. All right, so let's do part B. So the way I like to think about part B is, remember that the distributive law says that if you have some A times B plus C, and we've done this already, but this is just to explain something else. So this is going to be the same as A times B plus A times C, okay? Now I want you to think of this term over here, this whole term over here. I want you to think of this as an A, at some A, and then you're going to leave the rest intact, so t minus 3. So what we have to do is distribute this term here and over here to get A times t minus A times 3. But our A, remember, our A was essentially all this expression over here. So that is what we're going to do over here. So this is going to be our A, but our A is 7t plus 2 times t, which is the first term over here, minus, because we have a minus sign over here, minus 7t plus 2 times 3, okay? And now we have to use the distributive property here and here and over here and over here as well. Okay, so we do that and we get 7t squared plus 2t minus 7 times 3 is 21t minus 6. Okay, so this is 2 times 3, but then this negative sign is going to make it negative over here. All right, and this is going to become 7t squared. Then we have two terms containing t, and 2 minus 21 is going to be 19 negative minus 6. And this is our solution. Okay. All right, so part C, we're going to do the same thing we did in part B, because remember that expressions like this can be rewritten as, in this case, x minus square root of 3, x minus square root of 3, okay? So it is incorrect to apply this square here and here, because remember that that only applies if the two terms are multiplying each other. Okay, so in this case, we're not multiplying any terms because we have a minus sign over here. So the rule does not apply. Okay, so what do we do here? So we apply the same logic. Okay, we have the entire thing, x minus square root of 3 times x. This is going to be this x over here, minus the entire parentheses times the square root of 3, which is this term over here. Okay? So now we distribute the x inside the parentheses. So this is x squared minus square root of 3x minus, if we do square root of 3 times x and apply this negative sign over here, that's going to be minus square root of 3 times x plus 3. Okay, because we're multiplying these two together to get 3, and negative times negative is a positive. Okay. All right, so now we can simplify this a little bit more, because notice that we have square root of 3 over here, square root of 3 over here. So we have 2 of those with a negative sign. So that becomes negative 2 square root of 3 times x plus 3. And this is our solution. Okay. All right, so in this problem, we have to deal with cubic roots over here. Okay, but the same logic as before applies. So remember that radicals are just fractional exponents. Okay, so I'm just going to rewrite everything using fractional exponents. So this is going to be our 4 that it's outside, and this is going to be 27 times x to the power of 21, all of that to the power of 1/3, because remember that we have a 3 over here now. Okay, now we're going to apply some rules of exponents. This is going to be 4 times 27 to the power of 1/3, and then x to the power of 21, all of that to the power of 1/3. So now the 27 to the power of 1/3 is just the cubic root of 27, and that is going to be 3. Okay, because 3 cubed is the same as 27. And then over here, this is going to become x to the power of 21 divided by 3 times 1/3. It's equivalent. So this is going to become 12 x to the power of 7. And this is our solution. Okay. In part B, okay, we have to do the same thing. We have to essentially apply rules of exponents, but keeping in mind that the radicals are fractional exponents. So I'm just going to write the radical as a fractional exponent first, and then I'm going to apply all the rules that apply here. So this is going to be 5u squared divided by 15 times u to the power of 1/2. Okay? So remember that whenever we have expressions like this, okay, all we have to do is apply the following rule, which is, we have a square here. The rule says that if you have u to some power of n divided by u to some power of m, all we have to do is u to the power of n minus m, okay? And then 5 and 15 simplify a little bit, because 5 and 15 both have a factor of 5. So this is going to become 1/3 times u to the power of 2 minus 1/2. And 2 minus 1/2 is the same as u to the power of 3 divided by 2. Okay, and this is our solution. All right, so for the last problem, we have to solve for x if possible. So if no solution exists, we simply write DNA for does not exist. So remember that equations are essentially mathematical statements that says that two quantities are equal. So here we have to find the value of x that makes this whole term equal to 2. All right. So one way we can start is by subtracting b from both sides. So this is going to be 2 minus b equal to 1/4 times x. And now we don't write b because we just subtracted b from the right-hand side. And now I want to get rid of this 1/4 over here. So in order to get rid of that 1/4, I have to multiply the entire expression by the denominator. So this is times 4. And let me write it in black here. This is times 4. And when I do that, this is going to cancel with this. But now I have to distribute this 4 over here and over here. So this is going to become 8 minus 4b equal to x. And that is our solution. Okay. Now, if you plug in 8 minus 4b in this expression on the right-hand side, you should get 2. Okay, so for this problems, it is always a good idea to check your solutions. So whenever you're trying to solve an equation for x, you can always verify your own work. All right, so for problem B, remember that we have to leave x on one side of the equality. So here we can start by adding 31 on both sides to get x squared equal, not square root, but 31 on the right-hand side. And now we can take the square root on both sides. And we get that x has to be equal to plus minus square root of 31. And these are our two values of x. Okay. Now this means that if you plug in either positive square root of 31 or negative square root of 31 into this expression, you're going to get 0 as a result. Okay. All right, so for problem C, there are two ways you can do this problem. You can either factor that polynomial into a product of two simpler polynomials, or you can use the quadratic formula. In this case, I'm just going to factor this polynomial into a product of two other polynomials, or monomials in this case, because all we have to find is two numbers that when multiplied, they equal to 15, and when added, they equal to negative 8. Okay? So those two numbers are, let me write it here. Those two numbers are negative 3 and negative 5, okay? And if you expand this whole expression, you're going to get precisely the left-hand side of the equation above, okay? So what does this mean? So we're trying to find the value of x, remember. So this means that we're multiplying something times something else, and the result is 0. So that can only happen if this term is equal to 0, or if this term is equal to 0, okay? But if the first one is equal to 0, that means that x has to be equal to 3. And if the second one is equal to 0, that means that x has to be equal to 5, okay? So there are two different values for which this expression can be satisfied. Okay, so if x is equal to 3 and you plug it into the left-hand side, you're going to get 0. And similarly, if you plug in 5 into this expression, you're going to get 0 as well. Okay. So for the last problem, part D, again, we have to solve for x. So the first step, I'm just going to write it here again. So the first step, or you can actually do this in one step. So we want to leave the x on the left-hand side, let's say, and we want to get rid of this 3/2. So one way we can do that is by multiplying by the inverse of that on both sides. So we can multiply by 2 divided by 3 and 2 divided by 3 over here. And if I do that, this 2 is going to cancel with this one, this 3 is going to cancel with this one, and all I'm going to end up with is just x, which is what I want. So this is going to be x. And now 4 times 2 is 8, and 9 times 3 is 27. So this is the value of x that is going to satisfy this equation. Okay? So I hope this helps. If you have any questions, feel free to email me at any time, and I'll see you next time.